Donc aujourd'hui, vous allez avoir une présentation de Suzanne Dikker, qui est une amie et collègue de longue date. Suzanne, la première fois qu'on en a parlé, c'était Luc Arnal, qui était à New York University, que je connaissais de Paris, qui me disait: Ah, t'aimes bien les trucs art et sciences, il faudrait que tu regardes ce que fait Suzanne Dikker. Et effectivement, Suzanne était en train de faire des trucs incroyables et elle a travaillé avec des artistes aussi reconnus et connus dans le plan de l'art contemporain comme Abramovich, autant qu'avec des rappeurs ultra connus comme Residente et Bad Bunny. Donc, elle couvre un large spectre d'art sciences. Et à côté de ça, c'est aussi quelqu'un qui a énormément fait pour amener les neurosciences dans la vie de tous les jours. Elle a été la première à faire de l'hyperscanning, de l'enregistrement multicerveau dans des salles de classe pour comprendre ce qui se passe quand les enfants font attention ou pas à ce qui se passe dans la classe et à leur professeur. Et donc, ça a été une des pionnières de l'hyperscanning de groupe. Donc, moi, je faisais péniblement déjà 2, elle était à 14 personnes simultanément en salle de classe. Et une pionnière aussi du neurofeedback multicerveau. Et on va vous faire une démo justement à la fin de sa présentation entre la Californie, New York et Montréal. On aura 3 cerveaux synchronisés et on aura un feedback en temps réel à travers. C'est la première fois qu'on le fera à 3 personnes. Je pense qu'il n'y a même pas d'antécédent dans le monde. Donc c'est une bonne démo, quoi. Et d'un point de vue plus formel, donc elle est actuellement affiliée à 2 centres. Le centre du Max Planck Institute de New York, d'NOU, pour langage, musique et émotion, CLAMI. How you spell it?
Claim.
Claim, OK. Mais also, elle est affiliée aussi au département de psychologie de l'Université Amsterdam, VU Amsterdam. Et pour ces arts sciences, elle fait partie d'un collectif avec Matthias Ostrich plus Dikker. Et je pense qu'elle va vous montrer justement ce qu'ils font, qui est assez incroyable. Donc, à toi la parole. The floor is yours, Suzanne.
Okay, so I thank you so much for having me, even though it's virtual. I'm sorry I can't be there in person, but I hope that we compensate for it by doing a little trick for you at the end of the talk. I didn't understand all of what he was saying. I heard the word truc, which in Dutch means trick. So yeah, I do tricks, I guess. And I also heard that he gave away pretty much everything, so I might as well just stop and not give my presentation. But let me see. I will try to share my screen. I can't see the room. Is that correct? I can just see the...
I don't know. There is a camera also from the other side, right? For seeing the room.
Great. Hi, room. I just wanted to get a sense of who's there. So, amazing. I'll pin my... All right. So as Guillaume already said, I'm affiliated with Claim at New York University, and I also have running affiliations in Amsterdam, and I work with an artist, Matthias Ostrich, and we actually grew up together, and I'm very happy to be working with him on some of the projects that I'm going to talk to you about, like this one. I actually need to, I guess I need to get my timer here. Okay. So imagine you're at a party, and it could be, you know, maybe you're starting a new PhD program or whatever, and you're there talking to some new possible prospective PhD students, so you don't really know anybody, and you gravitate toward the kitchen because that's what happens in parties, and you strike up a conversation with a random person who happens to be standing next to you. So there are multiple different scenarios about how this might unfold, but there are on the one extreme end of possibilities. You have a fabulous conversation. There's an immediate click, and you feel like you could walk into the sunset with this person and live happily ever after. But there's also the other end of the spectrum where it's just a sequence of excruciating silences and maybe some small talk, and you're just trying to figure out ways to like escape to the bathroom and like get away from this conversation. And you yourself also then feel smaller and less smart, less interesting, less fun, and less enthusiastic about the thing that you're doing there, right? And so what we're trying to do is to see if we can translate, measure this elusive notion of feeling like you're on the same wavelength with another person or with the thing that you're experiencing together with objective measuring tools, right? Like brain activity measuring. And then the overarching hypothesis might be that successful interaction translates to increased brain synchrony, and the opposite is true for an unsuccessful interaction. And this effort falls under a larger, push toward understanding how the neurocognitive processes that we're brought into the world with support the social dynamics of real-world communication. We have been studying the social brain in the lab for a couple of decades now. And there's real good reason to study the brain inside the laboratory. You have much more experimental control, but you might want to test this laboratory model in real world social situations as well. And this might actually end up with a rich back and forth model where the real world data constrains or gives inspiration for laboratory studies and vice versa, right? And so to do this, I do both real world neuroscience and laboratory studies. I collaborate with artists, scientists, and educators, institutions outside of the ivory tower of academia. And I use in most of my projects, if not all of them, hyperscanning, which is basically the methodology to record brain activity or physiology from multiple people at the same time. And that gives you a lot of opportunity to study real world interactions that are not constrained. So, for example, in a series of studies, we recorded the brainwaves of groups of students and their teachers during their regular classroom activities. So the classroom is actually a great real-world laboratory for a couple of reasons. Learning is important. Obviously, it's a very socially charged environment, as you may or may not remember. I think probably most of you will remember. And then there's also, it also has some constraint that is comes natural with the environment. You can tell students to do one thing for 5 minutes and then something else for 5 minutes. And you can also tell them to sit still and shut up, right? Which is also very useful, especially for EEG recordings. So concretely, we collaborated with a couple of high schools in New York City, where we basically, we partnered with the class, with the students and with the teacher, and basically hijacked their class for the entire school year, worked with the teacher to design the curriculum, worked with the students. They were our co-investigators. We trained them to put the headsets on, which is very useful because we only had 50 minutes per class period. And so and it made them very involved and engaged participants, which I cannot stress enough how important that is. This is true for our laboratory subjects, of course, but it's very much also, if not more true, for real world subjects, because these were the most invested subjects that we've ever had. And when we tried this in another classroom where we didn't, work with them and gave them also educational opportunities, those students were much less invested in the actual process. So we recorded from 2 students and 2 schools, 12 students and teachers. We have other data as well, but I won't talk about this today. And we repeated data collection throughout the semester using different instructional activities and also some check baseline conditions. Pardon me. And then we asked whether the extent to which the brainwaves of the students and the teacher became synchronized during their learning activities was related to classroom engagement and classroom social dynamics. And we found, very unsurprisingly, that students enjoyed teaching activities that involved some interaction or some moving screen with video images much better than when the teacher did an old school style lecture or even, more, what is it, like archaic, where they grabbed their lesson notes and read them aloud. Students sometimes literally fell asleep during that. And we saw that actually their brain-to-brain synchrony during the lesson tracked their enjoyment of the classroom activities. We also saw that their interbrain synchrony during class was predicted by some individual factors, like how much students liked their teacher. And that was true both for student-to-student synchrony in a study led by Dana Bevilacqua, and also for synchrony between teachers and students. How focused students felt was predictive of their synchrony, and also how social students were, whether they liked being in a group or not, as like a predisposition. Were they the cheerleader type, or were they more the type that enjoyed reading a book in the corner? And also some of their empathic personality traits was predictive of their synchrony. And one thing that I think is relevant to note here is that this was true also for videos and lectures, which is where they were not directly interacting with each other, but they were co-present in the same room, experiencing the same content. And this tracks well with other research that shows that individual brain activity can change as a function of whether or not you're a socially predisposed person and you're actually in the presence of other people. So there's value to studying people in social contexts. You get at things that you cannot get at without the social context. Another example of from our data that I'm excited about, but still I need to emphasize needs to be replicated in a larger sample, is that we saw effects of class configuration and social interaction. So before the classes study, also because I don't really see you well, I want to make sure that whenever there's a question or a concern, just speak up. I don't actually see my I find it hard to focus on the chat. So just let me know whenever there's anything going on, please. Thank you. Anyway, so before the class actually started, we randomly assigned seats with the headsets that you saw in the video. And then students were asked to turn to the other student next to them, and look at each other silently for 2 minutes. Now, these were high school students, so you can imagine that it wasn't entirely quiet, and it was sometimes also a little, impressive for them because, maybe they were sitting in front of a student that they had a crush on, or that they hated, or that they were friends with forever, right? So there's stuff going on in this interaction. And then later, afterward, they turned to the lecture or the video or whatever the teacher was doing. And so this design allowed us to look at the synchrony between students who were sitting next to each other and students who were not sitting next to each other, but critically also between students who were sitting next to each other and had engaged in eye contact before the class started, and students who were sitting next to each other and had not engaged in this face-to-face eye contact. And what we saw was that it was this red group that showed persistent increased synchrony after they had interacted with each other. And interestingly, this was also the only group for whom we saw that their self-reported social closeness predicted their synchrony. So to contextualize this a bit, these were students who had known each other for since they were like 4 years old. They were in a school together that was from like kindergarten all the way up to high school. And so it's interesting to note that apparently they revive their social closeness if they actually interact with each other. It's kind of like, oh, I remember now how much I liked you. Or maybe it's actually a shared attention effect where they focus on each other and then they focus on something else, but they still keep, paying much more attention to the person next to them. And so this is the kind of thing that we might then bring into the lab and study further. So to sum up, interbrain synchrony predicts class appreciation, teacher likability, focus, social closeness, empathy, and group affinity. And we actually, I should have added this, we actually had a paper come out in Psychological Science yesterday that also shows that interbrain synchrony during learning is predictive of how much you remember later. So it's actually relevant to retention. And so these are, vastly different factors. And one might want to ask if there's some, unifying predictor between these, or are they each separate predictors of interbrain synchrony? Is there some sort of shared mechanism between these? So we started thinking about this in terms of shared attention. Now, if anybody studies attention or is like a cognitive scientist, they would think, well, that's a little bit of a cop-out, attention can be so many different things. And I would absolutely agree with that. But we have talked about attention in the context of many different sorts of social interactions. And we just, so if you take an individual, I bring to the table in a conversation with Guillaume or with Phoebe my own personality traits that may or may not make me more propense to pay attention. My own neural architecture, my brain is wired a little bit differently than Guillaume's. I come in like either sadder or happier, maybe a little nervous right now. And also with my expectations about the room. And Guillaume has his own expectations. He's literally contextualized within your group. So he has a very different understanding of the context, much better than I do. I don't know what his mental state is. His child is younger than mine, so he might be more tired. He has a slightly different brain, even though we're probably sort of the same age, and different personalities. And so that will affect how in sync our brainwaves would be with each other. I'm so sorry. And that is predictive by a bunch of other things as well, right? So we know, for example, from very clever work on cocktail party effects, that, brain entrainment is and synchronizing with external stimuli is determined by attention. So there's non-social stimuli that might act as interaction independent synchronizers. And then there's the actual social behavior of a conversation that Guillaume and I might be having that might lead to common ground and might depend on a lot of different factors, the language that we use, emotion, and a gaze direction. And that might in turn be predicted by or predictive of social closeness, right? There may be a bidirectional relationship there. And so what you can do, this is just one model of many that people have proposed. But the reason to illustrate it like this is that you can then start picking it apart into different factors and how they might predict synchrony. So, for example, I, as a teacher, or I am now talking to you, I am generating a speech that has temporal structure, and there is a nightmare scenario for me where you guys are all no longer paying attention to me, and your brains are completely somewhere different, and so you're not synchronizing with each other, and therefore you're also not synchronizing with me, right? And that's my ideal situation would actually be the opposite, namely that you're really, following, as we would say in Dutch, you're like hanging on my lips and you're following my every word and you're predicting the structure, and therefore your brain waves are completely tightly locked to mine and therefore also locked to each other's. The reality is probably more where some of you are very attentive and interested in what I'm talking about, and others may not be so synchronized with me, either because you're not as interested or because, you're tired or there's something else going on in your life. So by studying these different contexts, so we've had classrooms, collaborative learning, we had team interactions. I'll show you some interactive installations. therapy, different, and also different kinds of populations, mothers and children, and older adults and children, which Guillaume and I are starting to be interested in. And also also perhaps interactions with parents and children who are typically developing or who have autism. So, for example, we have a small sample that Guillaume and I collaborated on, where we had there was EEG recorded and video in adult-child interactions that involved either typically developing or autistic children, either between a caregiver and a child, or a clinician and a child, and they either looked at an object or they were engaging with each other directly. And while this is a very small sample, what became evident from even this small sample is that when you switch from an object engagement to a social engagement, both groups showed an increase in both eye contact when they're engaging with a caregiver opposed to the clinician. And we also saw that this increase was stronger in the brain synchrony for typically developing as opposed to kids with autism. And so what this drives home is that studying social disorders or any form of social interaction in a social context is critical to understanding this, right? It matters who you talk to, it matters what you do, and it matters who you are. And when it comes to understanding the drivers of these kinds of differences in interbrain synchrony, part of these could be due to the social behavior factors, but they also could be largely driven by differences in neural architecture, right? So, for example, here you might have, peak frequency differences where you get drifts between different brainwaves, or maybe there's completely different attentional profiles where somebody pays attention longer and for longer stretches than the other, which will all drive differences in interbrain synchrony. So we've also started asking whether providing feedback in real time about the way your interbrain synchrony is unfolding may help you improve social interactions, and this may be particularly valuable for social communication disorders or challenges or therapeutic contexts. Oops, sorry, too fast. So a while back, hey, why is this not playing? I don't know why. Anyway, so this is Matthias Oosterijk. I should get a better picture of him. There's just part of his face. There's no way you could recognize him. But anyway, about a decade ago, we started collaborating and creating software where we used the Emotus, which I will show here and you will also see later, to record data from multiple people at the same time and then translate the extent to which brainwaves synchronize in different frequency bands into different kinds of output. And so Phoebe is somewhere on this call as well, and she'll come on later. She is participating in this effort to construct different kinds of real-time hyperscanning feedback. So this, for example, is an example with two people where a dyad can brainwave synchrony is translated into the extent to which two heads merge in and out of each other. And so, as you can see, when the heads perfectly overlap, this score goes up and they're more in sync with each other. And this really allows people to try to compete with each other for their brainwave synchrony and test out different strategies. So I'm going to show you a couple of these projects. We've done these in several different formats at schools and people of different ages and across, the Northern Hemisphere, mostly in museums and festivals. And it's really turned out to be a super valuable tool for multiple things. So for education and outreach to begin with, it's fun. It's a very straightforward question. What might make your brainwaves sync up? What do you think? And you can help. And that different people can help. And so this particular neurofeedback visual that I just showed you, we've done at several places. And it also allowed us then to in a very, non-expensive way, test whether it's even possible to use these headsets in the real world and collect usable data. And so from an educational perspective, there's always this setup time, which then allows you to show people, their EEG in real time. And that makes it much more intuitive for them to understand that we're not dealing with like a straight up mind reading device. And we can also tell them that from individual experiences, we cannot give them anything back. They're just like one person in a large group of participants. And that as scientists, we can't tell them whether they should get married or divorced based on the results of their brain synchrony, right? And it also allows us to really bring this to a diverse participant pool, which I've already showed you before, and to test maybe these different aspects of the model, like how do all these different moments and predictors of synchrony, can we disentangle them from each other? So in the mutual wave machine, for example, we asked whether we put people in a dome-like structure where they were surrounded by visuals that reflected the extent to which your brain activity was synchronized, here translated into light patterns. So this, for example, is a video from a black box theater where you can see that whenever there's more synchrony, there's more light. And there's also a real-time video image of the person emerging behind the person that you're sitting opposite to, kind of alluding to questions of what it means to be on the same wavelength with another person, right? Like, are you really seeing the other person, or are you more projecting your own traits and expectations on the person opposite you? So in the mutual wave machine, we had over 5,000 participants across 10 sites. I'm going to show you some results from data that was collected in the Benaki Museum in Athens, Greece, where we had about 550 dyads. And we also created, which I won't show, a website that with results and a little bit about the methods for a general audience behind this. So in this installation, this version of the installation, half of the participants were told explicitly that what they were seeing was related to their brainwave synchrony, namely that more light meant more synchrony. And half of the people were not explicitly given this information, and where we capitalized on the fact that people walk through museums, sometimes understanding everything and sometimes not understanding everything about the artworks that they're experiencing. And so we can ask them whether, it might help. So this neurofeedback might help social communication. And aside from the neurofeedback, we asked people about their social closeness, their personality traits, and also their mental states. And as you can imagine, these were less than suboptimal conditions. So as I don't have to remind you maybe that there were good reasons to do research in the lab with high-end equipment, and there's reasons not to do this kind of research out in an museum environment where there's a lot of stuff happening around you, both from the point of electrical interference and people and interruptions. And so we offset this by recording from tons of people. So we threw away tons of data and also really cleaned it up very rigorously. And also by using metrics that are a little less sensitive to the instantaneous correlations and interference by surrounding noise factors. And so we found in our data that pairs who had lower personal distress showed higher overall synchrony. So this is the same kind of result that we saw in the classroom. So more empathy, more synchrony. And then for mental states and neurofeedback, we looked at changes over time, and we saw that those pairs who remained more focused while they were interacting with each other for 10 minutes in the installation showed an increase in synchrony over time. And interestingly, this is also true for the neurofeedback group. And here we see that only those people who were explicitly told that what they were experiencing had something to do with their social interactions actually showed an increase in synchrony over time. And so this is promising initial evidence showing that maybe we can indeed help use these kinds of tools to improve social communication over time. Another great benefit that I wanted to use the rest of my talk for is that we can use these installations as a sandbox to investigate and explore synchrony and social communication. And here I really wanted to drive down the value of partnerships between the science, the public, and artists. So for example, in the installation, the compatibility eraser, synchrony is translated into the motor speed of a card that moves faster as synchrony increases, and it slows down as it decreases. And this is an installation where people are really, really, really eager to try out all these kinds of different strategies that might sync up their brainwaves or not, to the extent that we actually had to shut down this installation because at like 8 p.m. because people were trying things that might break the machine or make it dirty or whatever, right? Like they were a little too enthusiastic about this. And even though in this installation, as you can imagine, it's kind of hard to get usable EEG signal. One thing that we really discovered is that people don't want to just participate in this. They want to debrief about it. They want to talk to each other about the things they tried. And so we capitalized on this in the neutral wave machine interaction by asking people, by asking people what kinds of strategies they used while they were in the machine. And we also prompted them to try to report back to us what strategies they used. And so based on their self-report, this qualitative analysis, we categorized them into different categories. And we found that, for example, those dyads who showed increased eye contact showed more synchrony who used eye contact as a strategy showed more synchrony while they were participating in the installation. So this is important to note. These are offline analyses after the installation. And then the same was true for when they were doing something together, joint action, and holding hands or talking about a topic, but not so much when they were thinking about the same thing. So what was anecdotally interesting is that a lot of people really wanted to try to make the machine light up by thinking about their favorite ice creams, but that doesn't work, at least not in EEG. And that's a very, EEG is a time-sensitive way of probing brain activity. And so maybe if we were using a slower tool that measures Bolt signal, like fMRI, for example, maybe we might actually get shared representations more, will increase synchrony more. And there's actually evidence from other groups showing that indeed people who think similar things, who are on the same page when it comes to the content of their conversation or the content of their thoughts or interpretations, they will synchronize their brains more. Another real benefit of working with artists is that they might ask us questions that may or may not have come up in the initially in our hypotheses as scientists. Like, why would I had an artist ask me why we would create an installation where light is synchrony is better. Like, wouldn't it be more interesting to do something opposite? And why would synchrony always be better? What is the role of individual agency in all of our work? And what's the role of individual agency and synchrony in our social interactions? So what I wanted to highlight here is that there's this movie E.T., which many, if not all of you, may have seen from the early 80s. And there's a scene in E.T. Way before we started, doing hyperscanning as a novel form of investigation, rediscovering it in the past 10 years or so, where Elliot and ET actually have perfect synchronized heart rates and brain activity. And the problem here is that it wasn't a good thing, because this was happening when ET was dying, and ET was dragging Elliot down with him. And so their coupling of the brain, of their neurophysiological signals was terrible. And it was only when this coupling was, disrupted, that Elliot could survive and thrive again and recover. And so we can ask these kinds of things with our visualizations as well. So for example, here's a visualization of our social network where you can then really make tangible questions around what it means to be the person that synchronizes most with the people around you. So from this visualization, the orange dot actually emerges as the hub. But it's a question of whether this is the leader or if it's a follower, and perhaps the person with the most interesting ideas or thoughts is the outlier, the purple one, right? And so even though these are not questions that are, aha erlebnisses to any of you in the room, what these visualizations, personifications, or work with artists to think about this does is it helps you formulate and crystallize your thoughts on this and translate it into experimentation. I'm going to skip this actually for time. But what I do want to highlight is that we are working, one group of artists that we're working with that has been super fruitful is dancers. So dancers are our go-to model organism right now to study synchrony. They're not the best model organism for some things because they don't move like many of us. They move much faster and more, elaborately and synchronously, but they are really good at testing out different kinds of ways of synchronizing with each other through movement and through brain activity. So we've been collaborating with this group for 5 or 6 years now. And we've done, for example, several performances like this one in Ballet National de Marseille. So this actually has audio. All of the work have visuals and audio reflections. It's just a little hard for me to give the presentation while the audio is also running on the background. But anyway, so here you see 2 dancers, and they're reproducing vignettes of the choreography of the dance groups that are all ask questions around synchrony or synchronicity. And you can see that their movements generate visuals, but you can also see that these flows are kind of pulled together and pushed apart. And that, in this case, is actually generated by the brain activity of 2 audience members who are puppeteering, so to speak, the dancers as they are performing on stage, kind of pulling them together and apart as a function of their brainwave synchrony. And so aside from performances, we've also had workshops where we've tried to really create a shared taxonomy of synchrony or synchronicity. Like, what is it that you're trying to get at? They would talk about dual utopia. As a linguist, we might actually refer to some of this as common ground that you're trying to reach, right? There's different ways and forms that you can synchronize with each other. There's differences that are really critical, like the difference between doing something simultaneous or together is super intuitive, but it's very hard to do on command. And it's also not trivial necessarily to measure and to quantify. And as a scientific community, we're struggling all the time with distinguishing whether we're talking about entrainment to an external stimulus or entrainment to each other, or if it's something that is really socially meaningful. Different units can synchronize with each other as mediators, like our bodies and our audio-visual signals. And then we use different vehicles like anticipation, predictive coding, sameness or distinctiveness, tuning, feedback. Some of these terms you might use in your work, and some might sound more, eclectic or out there. But the question here is whether we can actually gain something meaningful around this. And we're also designing, for example, studies that we can do during performance. So as if you're doing any kind of EEG research, you know that it's very prone to motion artifacts. And so one of the things that we're asking is whether we can actually do studies on stage where we're asking questions around the togetherness and simultaneity, combining both silent moments where we look at the brain activity and ask how anticipation of either togetherness or simultaneity might predict synchrony and movement during the phrase, and whether resonance stages after performing together might also be predictive of this. And we can then ask whether these constructs map onto different metrics, like different ways in which you can measure interbrain synchrony. And this is where there's tons of different ways that you can quantify interbrain connectivity. And so this is something that Guillaume has worked on a lot, and we've had a lot of conversations about together through our HiPipe pipeline, which we'll talk about in a bit. And as I already showed you, these different ways of strategies that people use, like eye contact and joint action, you may or may not have noticed in those graphs that these different metrics, projected power correlations and imaginary coherence, actually map onto different synchrony metrics in different frequencies. And interestingly, we see that those actually co-vary. Those dyads in the mutual wave machine who showed higher projected power correlations also showed higher imaginary coherence. And we can then begin to ask questions about what that might mean. Like, how do these different metrics at different frequencies interact with each other? So coming back to my example with Guillaume, I have attention patterns when we're looking at something together, when we're interacting with each other. And Guillaume's attention patterns are also going up and down, right? Like you never for 45 minutes, for example, engage with each other or with something without like dropping the ball on paying attention, right? So let's just agree on that. And then there's also, in this case, the way that how our attention co-fluctuates may vary. And that is directly measurable in how synchronized our brain activity is. So if my alpha power, which is an index of attention, goes up and down at the same time as Guillaume's, we can actually see that we can measure this and see that there are alpha power fluctuations go up and down at the same time. And that creates like windows of opportunity, so to speak, for maybe creating shared representations in these higher, that might be indexed by these higher frequency ranges or joint action representations in 20 hertz. And there's actually evidence by Saskia Havens and others suggesting that this is the case. Recall also that we saw that only the neurofeedback group in the mutual wave machine showed an increase in synchrony for the second half of their interaction. However, when we look at, if we compare two groups of sham and true neurofeedback, we saw that this interbrain synchrony effect neurofeedback effect goes away. So just to unpack this a little bit, what we measured in the way that the synchrony metric that we use to reflect synchrony in real time, maybe it's one of those metrics that is not meaningful, like the joint thought a metric, right? Or maybe it is, and maybe there's another metric that we might actually probe that might be more meaningful in a neurofeedback environment. So for that reason, we've created Hybrid Harmony, which is which can be downloaded on GitHub, which is led by Phoebe, who's on the call and will join us in a second, demonstrating Hybrid Harmony, where you can collect brain activity from multiple people at the same time. It uses lab streaming layer to stream the data, and you can generate different. It uses pre-processing parameters. This is all still in under construction, but critically, you can pick different connectivity metrics. You can use power correlations or a circular correlation or coherence, and try to investigate whether one versus the other might actually be a feedback tool that works better in one condition versus another. And so lastly, I wanted to highlight HiPipe, which is the hyperscanning Python pipeline that was spearheaded by Guillaume. I don't know if he told your group about this already. Really, with this pipeline, we're trying to unify a field that has become kind of Wild West, as one of my colleagues mentioned, where everybody uses different metrics to compute synchrony. Everybody uses different pre-processing dynamics. And so by streamlining this and allowing people also to use these different metrics, we're hoping to help paint a better and more cohesive picture around what we're actually measuring during social interaction. And so one thing I was actually thinking, so I was told, maybe like, can we pause for I want to get some feedback from you, because I was told that it was an hour talking and then questions, but I'm wondering whether I should skip the last thing and go straight to our demo, because of our, let's see if I can tell you. Are people still here?
Yes.
Yeah.
Okay, great. I'm so sorry. It's like, because most of you are like, there's people who are on Zoom, I can't see faces, and then I sometimes can see the room, and then it becomes so quiet. I'm like, am I the only one talking? So how, like, is it an hour and then questions, or should I like skip this last part? I think I have like 5 more minutes or so.
Yeah, no, go for it.
Yeah. Okay. Just making sure. Sorry if I'm interrupting.
I'm gonna sync with Phoebe while you're presenting that.
Oh, that sounds great. Okay, perfect. So you guys are going to set up. Yeah. Okay. So the notions of, and I wanted to just highlight one other very obvious example that we've sadly been experiencing a lot throughout the pandemic, is that we have some intuitions about synchrony and coordination for certain types of social interactions, but much less so for other types of social interactions. So rhythmicity, for example, really matters when we're having these kinds of conversations. So for one, obviously, it's very hard for me to give this talk to you because I don't really see your faces. I don't know if you're leaving the room or falling asleep. But there's also, we've experienced a lot of social interactions that do involve lots of faces interacting with each other. And even then we get Zoom fatigue, right? Like after engaging online, much more so than we do in real time. And this has to do, and this has more of a general feeling. But the rhythmicity of our interactions actually do matter, even though it's non-intuitive. And the reason why I know that this is not necessarily something that people pick up on is because even after 3 years or 2.5 years of doing Zoom talks and having Zoom conversations, there's one test that always seems to work, which is asking, and this is not going to work here because most of you are in the room, but say that you were all, I saw all your faces along the lines of this picture, for example, and I would ask somebody if it's somebody's birthday, and, I don't know, John raises his hand and we're like, oh, let's all sing happy birthday for John. And then people, even after 2 years of the pandemic, start singing happy birthday, all gung-ho and like happily and enthusiastically. And it completely breaks down after like 10 seconds or so, because even though Zoom is really good, at correcting for the delay, it's not enough for singing together and doing something rhythmic with each other, right? And it surprised me that people are still surprised about this, or were surprised about this even after this time. And it drives home that even though conversation is also even though in conversation, timing is also critically important. Like if you turn-taking dynamics, for example, are really tightly time-locked and can really influence the quality of a conversation, we don't really notice we don't really consciously notice. We only notice when we start making music together or singing together. And so this breakdown of face-to-face versus virtual interaction is something that we've begun investigating through installation. So for example, in harmonic dissonance quartet, we have 4 screens where people interact with each other. They were asked them to do a body conversation task, either facing each other. And that's not shown on this video, but you face each other and you move together without actually talking to each other, or through these screens, right? So we do a lot of screen-based interaction, and in these screens also there's a delay, and the delay is slight, but it's there. And here we replicate in our initial data. This is also a very small initial sample. We see that only through like face-to-face body conversation tasks do people show synchronous movements at this 0 lag that is necessary for singing together, for example. And that also drives home the sadness of the pandemic and makes it so great that we can actually come together in rooms and sing together and try to interact with each other face to face again. And so this importance of rhythmicity in our social interactions is also highlighted by a project that Phoebe and I did with Bad Bunny here on the left and Residente, who are both artists, musicians from Puerto Rico. They were Residente is my generation in his 40s, and Bad Bunny is more Phoebe's generation in his 20s. And they were coming together and trying to find common ground and things that might synchronize them. And I want to show you a very short clip where they are trying to remember a song together. And this really drives home how the rhythmicity how the rhythmicity supports them in creating this shared memory of a song. So I don't know if you understand Spanish, but I don't really think that it's necessary. Plus, it's close enough to French, I guess.
Intentamos cantar canciones que no supiéramos los dos. Pero gracias a la diferencia generacional, solo una canción conectó con ambos y fue un reggaetón. Con tu chulín, chulín, chumpla, con tu culín, culín. Estás diciendo un disparate, no sabes esa canción, tú no lo. ¿Cómo es? Con tu chulín, chulín, con fly. Abro la boca y mi lengua se cae y dice, ojalá, ojalá, ojalá y que tú seas mi madre. Ojalá, 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 ojalá y que tú seas mi madre. Ojalá, 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 ojalá y que tú seas mi madre. Me gusta como me guaya tu papaya, si tu papaya uva, guaya que ella va como guayaba, para allá va, para quitarte el diablo encima, sale la malla, se te ve la raya, los 21, dibuja la blancura, una pura, pura, torre pura, sangre, sangre pura, porque dejo el celibato y me quito de cura. ¿Me la juras? Nah, ni para tanto. Bueno, después de que me dé el canto, yo voy a todo contra cualquier santo. Asalto 4 bancos y me tiro de un barranque de manco.
So I don't know if you noticed, but there were definitely moments where he couldn't. No, I need to show this again. Where he didn't remember some of the lyrics, and they really, helped each other through this coordination and interaction. And it's like a very familiar experience for many of us, of course, right? If we're like singing any song together. So I used that time also to put on my headset, and I'm going to stop sharing. So we're going to just do a little fun, silly also demo where we're going to try to synchronize our brainwaves across, not across the Atlantic, unfortunately. That would have been even cooler. But I am in California right now. And Guillaume is obviously in Montreal, and Phoebe, oh yeah, there you are. Great. Sorry, I forgot to text you, but I'm glad you're there. Is in New York City, and so we're each wearing a headset, and yeah. I am not yet.
Share your screen?
Hold on 1 second, 1 second.
I'm only seeing myself right now.
Okay, I'm sharing now.
Oh, and I see Suze.
Feedback.
Mm.
But I think I just have 2 right now. So I'm missing Guillaume's headset.
But it just worked, right?
Yeah, like
Wait.
oh yeah, no, it's working. It's all good. Okay, so I have all 3.
It's my stream.
Okay, I'll just share my screen. So our network is basically, we're on the same network through VPN, and that's why I'm seeing like 3 headsets here. And I am computing synchrony value, that is coherence, through local network. And then this can be visualized with some processing code, but this could be visualized through other apps too. Are you guys seeing this?
Yeah.
Okay.
So who's who, Phoebe?
Oh yeah. Yellow is me, and pink is Suze, blue is Gil.
Yeah.
Yeah.
Okay, so Phoebe and I are most in sync right now. Oh no, then
yeah, so this program just shows like each of us moving like towards and away from each other, which indicates our synchrony value. And the size of the ball is sort of like average 1 to all synchrony over time.
yeah. And so we just actually got funding from the National Science Foundation, where students in schools can start generating their own visuals based on and sound systems based on their brain activity or their synchrony, and try to think about like ways in which they might make visuals and what it might mean, like what their brain data might mean. And Phoebe is helping generating a lot of that we're creating the basis for, not just us, but also others doing this work. And so that's also the purpose of hybrid harmony, that it's not a closed system, but you can use your own visuals. You can tag it on, it sends OSC or it sends LSL. You can make your own visuals or soundscape, use your own band frequency bands, and also different metrics.
Yeah.
I don't see. Oh, there you are. Cool. So I hope I don't know. I mean, like, it's clearly, as you can imagine, we don't really know necessarily what drives each of these synchronies, and so I don't know what else we can illustrate. We would want to try out something or compare it to each other, but maybe we can throw it open for conversations, for questions. I don't know. Or Guillaume, what do you think? You can sense the room so much better.
What? Sorry.
What do you want me to suggest, like a task?
No, should we start questions, or should people
yeah, sure.
or what? Or yeah.
I have to pick up my daughter soon, so let's go.
Yeah, exactly.
Yeah.
Ouais. Donc, est-ce que vous avez des questions sur la démo, sur ce qu'on voit là, ou sur le talk, sur vous pouvez poser vos questions en anglais si vous voulez, en français aussi, puis je pourrais traduire ou Guillaume pourra traduire.
I mean, in English would be best, because I understand.
I will translate anyway.
Translate. Yeah.
I do have some questions.
Yeah, go ahead.
First of all, I want to thank you, Suzanne, for that insightful talk. That was very nice. I'm finishing my master's currently on the subject of synchrony, so it really spoke to me. And I wanted to share with you my impressions, and saying that I'm standing more on your ideal situation side than on your nightmare situation side.
Okay.
I took notes, so
Great. Mhm.
it shows that I listen and I was connected somehow. So
Mhm. Mhm.
yeah, I just wanted to hear you. Maybe we could expand on something that was not brought up that much is and is relatively understudied is the idea of interspecies synchrony. I wondered if you had any insights to share with us about that, because as your projects are unfolded in museums and public spaces like that, I imagine having some kind of connection, not so much with humans, but other species would be interesting, no?
Absolutely. I totally agree with you. And I do know, I was just trying to look it up, and maybe Guillaume, you know that details. I know that people are beginning to study synchrony, maybe not neural synchrony, but definitely like synchrony, movement and interactions between dogs and humans, which is the obvious like human, and other species combo, right? We've been co-evolving for quite a while. Does anybody in the room, or Guillaume, do you know, I was trying to Google it while you were asking the question. Do you know any more details about this? I know that there are people in Marseille who are starting to do this work.
Yeah, well, there's been a lot of work on.
Can you build your mic?
Yeah, close your mic and.
Build the mic of your.
Can you hear me, Suzanne?
Yes.
Okay. Yeah, no, so I think already in the 80s, 90s, there were people working on horse rider synchronization. Typically, Kelso's work on that. And there are people working on synchronization more like physiologically with dogs.
Mm-hmm.
But currently, I'm starting actually a project with the department, not department, the faculty of veterinary.
Oh yeah.
Yeah, here.
Saint-Hyacinthe.
Yes, at Saint-Hyacinthe, yeah, with Eric Troncy. And we are working on human dog and human cats synchronization, yeah.
That's cool.
But the EEG of dogs and cats is tricky.
Yeah, I wonder if, Suzanne, you had any insights about that as well, the configuration of frequency bands.
Yeah, I don't know. I don't know anything about the like alpha peak frequency of dogs or
yeah.
but it's like, I mean, like it's a really interesting it opens up a world of possibilities of investigation of coevolution for sure. Yeah, plants and humans like figuring.
Dog hairs.
Yeah.
Hi. So I was wondering, since you found like that the rhythmic component was quite important in the synchrony, how will you deal with like motor artifacts in future studies to differentiate what is, well, kind of more accurately identify what is causing the brain synchrony? Is it the motor component? Is it state of mind? Is it what is shared between the participants?
Yeah, so I think I think part of the take-home message is that all of the above, right? So it really matters how you define, like the term synchrony is possibly problematic. It means something too specific and too broad at the same time, right? So and so I think we will only, like if we've studied human neurocognition for a long time, and we know, and we are used to disentangling different kinds of brain responses in that field, but somehow within our field of inter-brain coupling, we still keep on talking about it as like an overarching term. And I think it would be super helpful if we started disentangling and talking about it more in terms of, connectivity at different frequencies are differently meaningful, or connectivity in different types of metrics might be differently meaningful. And it's not true that, I mean, Guillaume, for example, has, authored really done very careful work around these kinds of differences. And then taking this step toward how that might map onto, things that we find socially meaningful and different ways that we connect with each other, I think is like a really important step in this. But it's very difficult. And it's also, we're still at a stage in the field where it's hard to like talk about our findings in those terms. With respect to your question around movement artifacts, so that is that's obviously a very real thing and problem for joint action. And I actually think that Guillaume, who is better here too. I don't mean to like boomerang all the questions toward Guillaume, but I do think he's a better person to answer that question directly, because he's done like very careful work around joint action, thinking about like these like the movements and the brain and how they're disentangled from each other or representing the same thing. To our school data, I can tell you that we did a very, I didn't do the cleaning of that data, but the PhD student who did a very careful and thorough job. And we also, at the request of our reviewers, looked at, regressing out smooth pursuit and some kind of like, more subtle movement related or like action, bodily related driven. And we didn't see that really bleed into the brain signal, but it's always a really important question. Guillaume, I don't know if you have anything to add to that.
I think like in a sense, that's why we need both lab-based experiment and out in the wild experiment, because in lab space you can control way more, and then once you have extracted the right marker, then you can transfer this knowledge to analyze the data in the wild.
Yeah.
But regarding artifacts, also the point is that you can now have also EMG recording and correct in real time the contribution of the EMG in the EEG, for instance. So that's where we are going right now, like full closed loop analysis, where you take the real time artifact. I'm using my brain.
I know, me too. So like a little pressure.
So I will close that. So the future would be like to have a large data set with artifacts that can help detecting in real time the artifacts and correct them. And we are making a lot of progress on that, like thanks to the community of brain-computer interface.
Yeah. Thank you.
I also have a question. C'est correct si je pose une question? Thanks a lot for the talk. It was really, really fascinating, and I aim to do some hyperscanning one day, so I really enjoy your talk. And I have a question regarding you said that a lot of factors can impact brain synchrony. You said, like, for example, personality. And I was wondering, because you tested so many people from different developmental stage or ages, and was wondering if there is an impact or effect of age, or in other words, is there a developmental effect of on brain synchrony?
Yeah, let me see. I have that slide, but funny, you should ask.
I'm developmental neuropsychologist, so it's
yeah, we're actually, this is I don't have like this is something that we're starting to do with Guillaume and Natalie Brito. We are starting to think about, like, in caregiving, you have parents and children, but you also have, sorry to unpack this. This is a model that I showed. Here you have the dark red one is an older adult. Then there's a child. The child is yellow and the parent is blue. And so what we see that in terms of alpha peak frequency, for example, right, which I talked about as one like possible predictor, like neural architecture predictor of synchrony, there's you see this U-shape in aging where children have fairly low peak frequency, and then it goes up as you're a young adult, and then it goes down again as you become an older adult. And so that is one way in which you might expect, just based on like basic differences in age, you might expect higher synchrony between older adults and children. And then there are other reasons why you might also expect that the older adult and the child actually map onto each other better in the synchrony sense, that is, than the adult to the child, for example. So, children and older adults might entrain less well to the signal, and also in their social behavior, they may have less coherent discourse. Younger children and older adults are shown to have less coherent discourse. On the other hand, and we also know, for example, that older adults and young children both show less prediction during conversation. But here's where interesting dissociations then come along, because older adults are able to predict, right? Like they've done it throughout their life. They just change their processing strategy throughout their lifespan, but children are not able to adjust. So here you might see it kind of an adaptation difference where older adults may be better at adapting to the language, for example, of young adults or children, where children just don't have the systems in place yet to do this adaptive behavior, right? So you might then expect different changes over the course of a conversation where older adults do adjust and young kids do not. So these are just some examples of ways that, like throughout development and aging, you may expect actually differences in synchrony, which may be socially relevant, right? So and this is something that you're probably going to be able to speak to much better than I am, but a lot of the research on like interactions are between parents and kids, and not so much between grandparents and children, who also play an extremely important role in the child rearing. And the field is turning to I'm hearing more and more people talk about, hey, grandparent-child interactions are really prevalent and also very important to study. And so you can think about like very meaningful and significant ways in which these might differ from parent-child interactions, and sometimes be better and sometimes maybe not. But probably the end being that we all have our functions, right, as we do in social interactions. But I don't know if that goes toward what you were trying to get at.
Yeah, absolutely. Yeah. And do you have any other questions?
I do, actually, if I may.
Yeah, go ahead. Yeah.
There's one other topic that is relatively understudied as well in the intersubject correlation literature, is the synchronization of the peripheral activity. I wondered if you had any projects involving synchronization of heart rate, for example.
Yeah, so we are, I don't yet, but we are beginning to do this kind of work. We have a wearable device in Motabits that we're co-developing, and that I think, Guillaume, you have one or two, or no, you in Motabits as well, or no?
Not yet, but we're working on that.
But I mean, there is actually a fairly rich literature on synchrony in physiology. We're just not talking to each other that much yet. So Tessa West, for example, at NYU has really fantastic line of work on physiological linkage. And the same is true for Emily Butler, who unfortunately passed away recently. She has a very rich, research program with very careful analysis around linkage in physiology, showing, and so Tessa West works, for example, is a lot about like patient doctor relationships or friendships, etc. So it's not at all understudied. It might actually be a field that is like much more evolved in ways, or like has been, going on for a little bit longer than interbrain synchrony in the recent, boom of interbrain synchrony research. But combining them, we have data that combines the two. And that basically shows that the more data you use, the better it predicts, outcomes. But what the individual contributions is of these different is an open question. It's a different source, right? So a source of data, and you might want to think about it very differently too than brain synchrony. Are you doing that work? Is that what you're asking, or?
Yeah, I'm looking at heart rate synchronization and synchronization of functional MRI activity.
Mm-hmm.
Large-scale individual subjects, like lengthy recordings in the same subjects. It's called the Courtois Neuromod project.
Great.
The data is going to be available if anyone's interested in your group.
Amazing. Yeah, I definitely would love to. Maybe Guillaume, you can share that project. Would be great.
Yeah, sure.
Yeah, the PI, you work with Pierre Bellec.
Yes, I do.
Yeah, so he's a member of Cerebrum. I can put you in contact with him.
Oh, fabulous. Thank you.
Yeah. Maybe one last question. You had a question. You still have...
There and one more. I was just, I'm an undergraduate student, so I don't know if my question is going to be a bit of a lower level.
No
but,
problem.
What's imaginary coherence?
Oh, Guillaume, don't go away. Can you explain it? I'm serious. Like it's just that you don't take anyway, please. I mean, Guillaume is really our physicist. Can you explain the math behind it to the undergraduate? It's not a low level question at all.
You know what a spectrum is?
Yeah, well, EEG spectrum.
Yes.
Yeah.
So if you take two spectra, you can combine them to look at how they evolve in time. And that's coherence. So that's like the first base. And then to go to the imaginary coherence, since spectrum are actually computed with Fourier transform that is with imaginary number, the imaginary coherence is just the imaginary part of the coherence. And why we care about imaginary part of the coherence? Good question. Because if you see the imaginary circle, so the real part, the zero, is zero angle. It means like zero phase delay. And usually zero phase delay is associated with volume conduction. It means like it's not real synchronization. It's just like you have a common source that tends to give two different points the same phase, but it's not linked to two activities, just a common source that affect the two things. So to get rid of this case, you take just the imaginary part and it removes the zero delay.
You have to take a few classes in phase correlation.
Well, we can discuss later, but roughly the guess, yeah.
Thanks.
Do you mind to answer one last question? Because I didn't see. Yeah, go ahead.
Yeah, actually, but it's a simple question. Have you, or do you know of any work where you would study, let's say, two people playing chess or Go? In other words, to...
Oh yeah, Go I think has been studied, and chess possibly as well, for sure. There's a lot of research actually in this field studying collaborative game playing or collaboration and competition versus each other. That's a very rich field. There's actually Artur Szejumski recently led a meta-analysis on that work in IFNIRS. And so I'm looking at that it's published in eLife this year. Like looking at that work, I think we'll probably give you some references on that. I don't know who exactly offhand, but yes, for sure. I think I do remember Go as a game that was played in one of the studies. Chess, I don't know. Are you asking for the collaborative competitive aspect of it?
Well, yeah, actually, I was curious to see, and plus, since people don't move too much, probably it's better.
No, for sure. Yeah. No, it's a great question. Yeah. Mm-hmm.
I was curious.
So thanks a lot, Suzanne. Thank you for answering all these questions. I might have some other questions, and I think that some people in the room have other questions, so we might email you or...
Oh, for sure. Yes, please. I'm so sorry I won't be there in person. I do hope that in the next year or so we can find a way for me to come over and visit you guys.
Yeah, are you thinking coming to OHBM or?
Oh, I don't know. I wasn't thinking about it necessarily. When is it?
Yeah, it's in Montreal. That's why I'm asking.
Yeah, no, when is it? I figured that. but
July.
when- In July. Oh, no, I will be in Europe in July. Oh, damn.
Okay, but thanks a lot for your talk. It was really, really nice and really interesting. Thanks, Phoebe, and thanks, Guillaume, for the demonstration. And hopefully we'll see each other in another time soon.
Yes, that would be fabulous.
Thanks. Bye-bye.
Bye.